Today we're going to talk about X and Y intercepts that happen both in a graphical form and tabular form, and we'll kind of talk about similarities or differences between them and how you can kind of keep track of what's happening. So these are both vocabulary words that you have seen before and should remember, but an X-intercept is, that's right, the point, or I guess I should say points, plural, that touch the x-axis. Okay, so they obviously need to touch the x-axis in order to be an x-intercept. So what does that mean? What do all of those points have in common? So if we look at, let's see, I'll draw this graph here. If we look at a graph here for a second and it's an x-intercept, that means it's happening here. Here's the x-axis, so this is the x-axis. What do all of those points have in common? So every single one of these points, let's say we have a few here. So this would be the point -1, 0, and -3, 0, or 2, 0. What do those all have in common? And obviously there's lots more. So those all have some sort of x-coordinate and then y-coordinate of 0. Every single x-intercept is going to be some number and then 0 as the y-coordinate. Okay, that's important to know. Y-intercepts, on the other hand, then, would be point that touches the y-axis. Okay, so that's important to know. So here's our y-axis here. What do all of these points have in common? So if we have some y-axis points, this would be the point 0, 5, or 0, 3 would be that point right there. Or 0, -4 would be this point. What do all of those points have in common? Well, they all have a 0 for an x-coordinate, and the y-coordinate is some number. Okay, so they're all 0 and then some number. 0 is the x-coordinate and y is some number. Okay, now let's talk about how many possibilities are there for x and y intercepts. Why did we say plural for x-intercepts, but it's only one point for a y-intercept? So remember, we're in our functions unit. In order to be a function, x's can't repeat, meaning it's got to pass the vertical line test. And so we could have a graph that crosses that x-axis however many times. You know, I could have however many if our x-axis kept continuing down this way. Doesn't matter. So we can have 0, so can have 0 to technically infinite possibilities. Okay, you could have 1 x-intercept, 2, 3, 4, 5, 10, 12, 17. You could also have none. It could also be the case that if you have a graph, it's not going to cross the x-axis at all, and then it would have no x-intercepts, and that's also possible. For y-intercepts, in order for it to be a function, again, it has to have, it's got to pass the vertical line test. So if we have like this, it touches the y-axis twice, that's not going to be a function. That doesn't pass the vertical line test. So this can't even happen because it's not a function. So to be a function, you can have 0 or 1 possibilities. The maximum number of times it will cross the y-axis is once in order for it to be a function. Okay, so keep those in mind. Now let's look at some actual examples of this. We're going to be finding the x and the y-intercepts. All right, so here we just have a graph. They have not given us the equation for this at all, but we need to find the x-intercepts and the y-intercepts, however many different things occur. So for x-intercept, That's going to be the place it crosses the x-axis. So as I'm going across the x-axis, I notice that it touches there, the graph touches there, and it doesn't touch any other place. So we're just going to have one x-intercept here. And the coordinates of that, remember, if it's an x-intercept, the y-coordinate is going to be 0. Our x-coordinate is going to be -2. We're going to do the same thing for y-intercept. We're going to look to see if one exists. So we're traveling along our y-axis. I find a point where it crosses. So that means we do have a y-intercept. Remember, every y-intercept has 0 as its x-coordinate. And then the y-coordinate we're going to get from the graph, which is 4. It crosses at a +4. Now, if it crosses the x-axis more than once, then you would just list off multiple points, whatever that means for the question. If it doesn't cross the y-axis or the x-axis, one or the other, or both, then you would just say none. It has no x-intercept or no y-intercept, depending on the situation. So that's what it looks like in a graph. Here's what it looks like in a table. So we're just looking at a table of values. Again, we have no idea what the equation is for this at all. But we're going to look for an x-intercept. And remember, and if it helps to kind of give you a visual, you could either plot these points if you wanted. You could also plot them in a Desmos and see what they look like. But if we're on the x-axis, that means that our y value is 0. So looking at our chart, our y value is 0 happens here. So our x-intercept is going to be the point 5, 0. And the same idea is going to happen with a y-intercept. If we're on the y-axis here, we know that every single point there has an x-coordinate of 0. So looking at our table, we're going to have 0, -6 as our as our y-intercept. Okay, so x-intercepts, just to reiterate one last time, x-intercepts are points that touch the x-axis. So it's going to have some sort of number for x and 0 for y. It's kind of backwards from what you think. X-intercepts are going to have a y value of 0, and y-intercepts, they're going to cross the y-axis. That means it's going to be 0 some number y. So it's a y-intercept, which means the x-coordinate is going to be 0.